So we are going to look into these particular functions. They are functions having more than one independent variable. I told us the meaning of independent variable. Is anybody here without knowledge of the meaning of or the meaning of the word independent variable? Is anybody here that don't know the meaning of independent variable? Thank God, all of us know it. So look at it. Okay, you don't know the meaning. But I've explained this. I said when one is outside, the one that's outside depends on the one inside. I will not explain again. The one that is outside depends on the one inside. So the one outside is the one that is depending on the one inside. And the one in which the one outside is depending on is called independent variable. So now this one, this is f of x. F of xy is actually now is equal to z. Now, what does that mean? It means inside this function, what we are dealing with is what? X and y. We can see have it also. We can see have it like this. X, y, then the u is equal to what? Z. How many are these now? Three. So f of x, y, and w is that taken out? So we are going to what? To work on this one. So the first thing is solution. So we have the first one. We have sine of x raised to power 3 plus y raised to power 4. Now, this type of function is called composite function. And can anybody tell me the reason why it's a composite function? Okay, because it's a function inside another function. We can see this function, that is x raised to power 3 plus y raised to power 4. It's a function inside sine. Is that taken out? So what does that mean? It means that we are having what? Two functions. It's like a pregnant woman. Is that taken out? It's like a pregnant woman carrying a baby in her belly. Is that clear now? If the woman, it's not the only woman, it's not the woman that only eats. The woman eats and the child inside also what? Also eats. So it means what? Yoruba will call it abara meji. Meji means two. So a pregnant woman is not only what? She's not the only one existing. She's existing and the baby in her what? In her womb. So that is exactly what this function is. So I'm going to take the baby outside and work on it. Then I will now work on the mother. Is that taken on? Yes. Alright. So we have x cubed plus what? Y raised to power 4. Okay. And sine also. Is that taken on? And sine. So, but the direction now, what will determine my direction is it the z? Okay, I'm coming, let me just put the z. 1. Is it dz over what? Dx. So if it is dz over what? With respect to what? Dx. So it means that what? I must differentiate what? Only x, leaving what? Y. So if I'm doing that now, but I want to differentiate what? This sine. I tell us that when we differentiate sine, we give what? Cos. I explained that day that when a Christian, when a sinner repents and give his life to Jesus, become what? A Christian. So when you differentiate what? A sine, it give you what? Cos. From sinner to Christian. So thank you very much. So when we differentiate this sine, it will give us what? Cos. With everything inside again. Is that taken out? Yes. But what we are going to do now is this. So we are going to work on the one inside. Because we have differentiated this one, we have obtained this one. That is, the only thing that changes up the sign. Change to what? Cos. We have differentiated to cos. And this one is repeating again. Is that taken out? So we want to work the one that is inside now. And we are dealing with what? X. Okay. So when we differentiate this one, what does it become?
3x squared.
3x squared. Do we all agree?
Yes.
For this one become what?
0.
So we have 3x squared. So you have to put your 3x squared here. And you are done with it. So now, if you are to do the z over what? The y. The same process. Differentiating this one will give us what? Cos into what? S raised to power 3
plus y.
So we are going to differentiate this one. But we are not differentiating what? With respect to what? X again. We are differentiating what? With respect to what? Y. So this one will become what?
0.
Very good. And this one will become
3y.
4y raised to power what? Cube. Which is what? 4y raised to power cube. So which is this one. So we can still work it to the square z over the what? Should we work on that one also? Should we do it? So when we have the square z over what? The what?
S squared.
S squared. So it means what? Okay, let me put it this side. Let me put it this side. So I have the square z over the x squared. So it gives me the over the x into what? The z over what?
The x.
The x. So the over the x over what? This one. What do we obtain there?
3x squared
3x squared. I mean
cos
into what? 3
cube
oh, sorry. S cube
plus y
plus y is to power
4.
Now look at this function now. You see that this one is outside. This one you see, and this is the function. Join to another one here. And another function inside it again. Let me make it clear again. This is a function separate. This is another function, but it's having another function inside. So, and what we are going to do here is what we call, we are going to use product rule. Is that okay now? We are going to use what? Product rule. Okay, in product rule we have something like this, the y, something like this. In differentiation, the y, v, the u over what? The x plus what? U, the v over what? Over the x. So we can treat this one as u and treat this one as what? As what? V. I told us that when we are reciting, whenever we are reciting A, B, C, D, we recite what we call u before v. Is that it now? So now if you differentiate, okay, now this is v, right? So it means that what? We are going to have
V.
cos, because this one is what? V, and this is what? V. So we have into x squared cube plus what? Now we are going to differentiate what?
U.
The u over what? The x. Is that it now?
Yeah.
So we are going to differentiate. So I can just change this one to what? Something like this. Abi? It will make sense. If I just put it like this, to make more sense. So now, look at, we put v, look at what v is, we put it there. So I'm going to do what? The what?
The U.
The u over what?
Yes.
Yes. So this is u now. We are going to differentiate it with respect to what? With respect to what?
The
With respect to the x. So we are having
C.
3s squared. I mean, when you differentiate this one, what does it become?
6x.
6x. I mean, so you are going to put it here. 6x.
Plus.
What is here?
Plus.
Plus. So now, look at this. What is u now? This one. Abi?
3x squared.
3x squared. Abi? So let's differentiate this one. You know, if you have to differentiate this one, two things will happen. This one will become what? Sine, which is negative sign. Is that clear now? And we are also going to differentiate the one inside with respect to what? X. Is that clear now? So we are going to differentiate this one with respect to x, and we are going to change this one to sine, but that sign will be negative. Is that clear now? So we are going to have what? Minus sine everything s cube plus what? Y raised to power what? 4. Then again, differentiating the one inside with respect to what? So we have what?
3x
squared.
3x squared plus what?
0.
So we have 3x squared. So we have 3x squared. 3x squared. Now, if you look closely, you see that this one, this is 3 now. And this is 3, Abi? Okay, 3 times 3, what do we get? 9. This is x squared, this is x squared, what do we get? Let's say power 4, right?
Yes.
But this is minus and this is plus. What do we now have?
Minus.
So we can bring this one to the front, becoming what? 6x, Abi? Okay, into what? Cos what? X raised to power 3 plus what? Y raised to power what? 4 plus this one will now, oh sorry, it's minus because this is plus and this is minus, Abi? So this one and this one become 9x raised to power 4, Abi? Sine what? X raised to power 3 plus what? Y raised to power what? 4. And that brings us to what? To the end of what? Of this one. So this, you can see it's very long, but don't worry, keep practicing it, you get it. So because I don't want to waste time, so let's move to this one. So we have this one, which is number 2 here. We have z is equals to cos into 5x squared plus y raised to power 3, right? So in this place now, this one we differentiate it. When we differentiate cos, you give us what? Minus. If a Christian say it's not having Jesus again, you become what? Minus at a sinner. Is that clear now? Yes. So we have minus sine. Everything inside 5x squared plus what? Y raised to power 3. Now, differentiating, dz over what? Dx, have it? So I'm only differentiating what? X, have it? So we have 5x squared plus what? Y raised to power 3. So this one will now become what? 10x, have it? Plus what? 10x. So we have 10x. So if you multiply this 10x with this minus, it gives us what? Minus 10x sine into what? 5x squared plus y raised to power 3. Is that taking, everybody? Is that taking?
Yeah.
Very good. So we have dz over what? Dx. Now, the way we differentiate this one, so this is the way we are going to differentiate again. So we have minus into what? 5x squared plus y raised to power 3. But this time around, we are differentiating what with respect to what? Y. So this place become what? 0, and this one become 3y raised to power.
What? Dy ds. Z over d.
Sorry, dy. Sorry.
Okay.
So now this one will now become what? 3y squared. So this one multiply with this one. We have 3y squared. Abi? Sine what? 5x squared plus y. Y raised to power 3. Is it taking? Is it clear? Very good. So now the last one here is actually number 3. Number 3. In this number 3 now I have
Tan.
z is equal to what? Tan into what? 2x to the power 5
plus 5xy
plus 5xy
y squared
plus y squared. So I hope you can get it the way I'm doing it.
Yes.
Is it clear? Okay, very good. So now we have the z over what? The x. So we are working on what? On what? On y and z and what? On z and x. So when we differentiate time, it gives us sec squared. Sec squared. Sec squared. With everything inside, is that taking out? I will not do the long process I do before. So I used to do, but let me just break it everything here. Look here now. If you differentiate this one, what does it become? 10x raised to power 4. Power 4. So when we differentiate this one, x, only x, becomes what? 5. Just 1. When we differentiate x, it gives us 1. Abi? So 1 times that 5 gives us 5. Abi? So we are not going to have what? 5 what? Y. This one become what? 0. So we are going to just have it like this. So we now have what? 10x raised to power 4 plus what? Y raised to power 5y. We have sec squared into what? 2x raised to power 5 plus 5x plus y squared. Alright? The last one is just the z over what?
Y.
Y. So in this form, it's still repeating this same thing. Is that clear now? So we have sec squared, into what? 2x raised to the power 5 plus 5x y plus y squared. But the only thing I want to do is that we are differentiating with respect to what? Y. So this one becomes what? 0. This one becomes what? 5x. We have differentiated y and become 1.
5x.
So 5x, and this one become what?
2x.
2y. So 2y. So therefore we now have 5x plus what? 2 plus 2y. Abi? Okay, into what? Sec square. Abi? Into what? 2x raised to power 5x plus y squared. Okay? This is the end of the question. So, is anybody with question there? I want to ask question.
Why is the 5x plus 2y coming in bracket?
Why is it coming in bracket?
Yes.
Why is this one coming in bracket? You must put it because this is plus between them. This set is not for only 2y, it's for both of them.
The first step.
First one.
The first step.
This one. This one. This one.
I don't understand now.
When you differentiate tan, it will give you this one. This one still repeats itself. That's it now. This one still repeats itself. But when you differentiate with respect to what? You differentiate with respect to x. Is that it now? So this one to this gives you what? Then you reduce this one by 1. Give you this one. Is that it now? Differentiating the x here, it becomes what? 1. When you differentiate x with respect to x, 1. So we have 5y. So this one we are not working on y, it becomes 0. So that is it. So class work now. What to do?
So fast.
Wait, let me see now.
So we have 5x raised to the power 3 plus 5 raised to the power 2, and we have 6x raised to the power 4 y plus 3x power 2 times into 5x raised to the power 4 plus y raised to the power 2. Thank you very much.